Welcome to the deep dive. Today, we're looking into something really shifting the ground under AI development, specifically large language models, or LLMs. Their progress has been, well, staggering, hasn't it? Especially complex reasoning like coding or math problems.
Absolutely remarkable. But there's always been this big challenge. The standard approach, the sort of received wisdom, has been you need more data, more compute power to get better reasoning. It's called the reasoning scaling law. And honestly, it means huge costs, and you often hit a wall, diminishing returns. It's a major barrier.
Okay, right. But you're saying there's something new, a framework that challenges this whole bigger is always better idea for LLMs.
That's exactly it. It sounds almost radical, I know.
So what is it? How does it work?
It's called data efficient distillation, DED for short. It comes from researchers at ZTE and China Mobile. And here's the first big aha moment for you listening, this DED method. It achieves top-tier performance with, get this, only about 800 carefully selected examples.
800. Seriously.
Seriously. It completely bypasses that need for massive scaling. It suggests that maybe the way you use data matters more than just the sheer amount. Strategy over volume.
Okay, let's dig into that scaling law problem a bit more first. LLM reasoning often involves chain of thought, right? COT.
Exactly. Breaking down problems step by step. It's seen as a really key step towards, artificial general intelligence, AGI.
And the main ways to improve that COT reasoning currently are things like RLVR, that's reinforcement learning, with a verifiable reward, and SFT, supervised fine-tuning using distilled reasoning paths.
Those are the dominant methods, yeah. You see big models like DeepSeek R10 using large-scale RLVR. And distillation, using a powerful teacher LLM to train a student, that's gained a lot of traction, too.
But both expanding those reasoning examples, the COT corpora and the complex training stages, they feed into this scaling law idea, don't they?
They do. The underlying assumption is always more data, more compute equals better reasoning.
Which creates this huge barrier to entry, sky-high costs. It really limits who can push the boundaries.
Precisely. And that's the problem DED is designed to solve. It wants to optimize what's called the Pareto frontier of distillation.
Meaning getting the absolute best results for the minimum resources. The sweet spot.
Exactly that.
Wow.
And it does it through three main innovations. They took inspiration from reinforcement learning concepts like on-policy learning from your own attempts, and using diverse strategies, diverse rollouts.
Okay, 3 innovations. If they're not just using more data, what's the first one? You mentioned something about picking the teacher model differently.
Right. So conventionally, you just look at benchmarks, find the model with the highest score, and say, okay, you're the teacher. Seems logical.
Yeah, it makes sense. Pick the smartest one.
Well, DED argues that benchmark scores aren't the full picture for teaching effectiveness. Raw model strength doesn't automatically mean it's a good teacher.
Ah, like that brilliant professor who can't actually explain anything simply.
Exactly that analogy. So DED uses what they call a smoke test. They gather a few top candidates, these large reasoning models or LRMs. For each question, they just get one sample reasoning path, one COT response from each candidate. Then, and this is the clever bit, they run quick distillation tests on the student model using those samples. The teacher is chosen based on how well the student learns from those quick tests.
So it's testing the teaching, not just the knowing. Very neat. Okay, what's innovation number 2?
Innovation 2 is about the data itself, a curated smaller corpus. There's this known trade-off, you see. If you scale up distillation with lots of data, the model gets better at the specific tasks it was trained on, that's in-domain reasoning. But often, its ability to handle new, different tasks out of domain or owed performance actually gets worse. It becomes less flexible.
Right, it gets specialized but loses general smarts. So DED's fix
Is a much smaller but very carefully curated corpus. Quality over quantity, basically. Finding a balance between that in-domain skill and the owed generalization.
What does carefully curated mean in practice? What are they filtering for?
Several things. Strict quality checks. They filter out super long responses like over 16,000 tokens. They check for correct formatting, like the specific think tags. And obviously, correctness is key, using ground truth or even another LLM as a judge.
Okay, standard quality control.
But here's another clever part. Question compression. They check if the student model already finds a question too easy. If the pass rate is above a certain point, they filter that question out.
So they only keep the hard stuff, the things the student actually needs to learn.
Exactly. Focus the effort where it's most needed. It really suggests we might be wasting compute on problems the models already grasp.
That makes a lot of sense. And the third innovation, You mentioned diverse reasoning.
Yes, developing diverse reasoning trajectories. The goal here is to make the student genuinely understand how to reason, not just memorize one specific way to answer.
Like showing different ways to solve the same math problem, so you learn the concepts, not just the steps for that problem.
Precisely. Again, inspired by reinforcement learning's diverse rollout strategy. For each question, they generate multiple reasoning paths. Then they calculate something called the Levenstein distance between these paths.
Levenstein distance. That measures how different two strings of text are, right?
Yeah,
Like how many edits to turn one into the other.
exactly. It gives a mathematical score for how unique each reasoning path is. They then select the farthest P responses, the most different, most diverse set of solutions. This pushes the student to develop more robust, flexible reasoning skills.
Okay, strategic teacher. Curated hard questions, diverse solutions.
Yeah.
So the payoff. What did DED actually achieve?
This is where it gets really impressive. DED hits state-of-the-art results in math reasoning and code generation. And it does this with only about 0.8K, just 800 of these carefully curated examples.
Wow, that really does blow the scaling law idea out of the water.
It absolutely challenges it. Look at math benchmarks like AM 2024 and 2025. They used a corpus built from just over 200 initial questions that's only 20% of their raw sample pool enhanced with diversity. And they got accuracy like 81.87% on AIM 2024, 77.29% on AIM 2025. Really strong results.
And you mentioned it even outperformed the teachers.
Yes. Get this. The performance surpassed other models trained on the same base but with larger data sets. And crucially, it even outperformed the teacher models it learned from, like QWQ32B and DeepSeek R1.
That's counterintuitive, isn't it? The student surpassing the master with less data.
It really validates the efficiency of the DED approach, especially when you don't have massive resources.
And it wasn't just math, right? Code generation, too.
Yep, it adapted very well. They tested on live code bench LCB, easy, medium, hard problems. The base model was already decent on easy stuff, so the main gains were in the medium and hard categories, where the curated diverse data really helped.
And the result there, still state-of-the-art with minimal data.
You got it. They used just 230 initial code samples, expanded to 925 with diversity enhancement. Hit SOTA on LCB, again outperforming the teacher, shows real adaptability.
What about generalization? That OD performance you mentioned earlier. Did the focus training hurt its ability to do other things?
It's the fascinating part. They tried training on a mixed corpus, about 400 math examples, 400 code examples, so still only around 800 total.
Okay, mixing the domains.
And the model achieved SOTA performance in both math and code simultaneously from this mixed training.
Yeah.
But even more importantly, this mixed corpus DED model showed improved performance across a whole range of general knowledge and common sense benchmarks. Things like MMLU, BBH, GSM-8K.
So training it intensely on two specific things made it better at everything else.
It seems so. One really striking example was the AIDER benchmark score. It doubled. Went from 12.4 to 25.8.
Doubled. That's not a small improvement.
Okay, so why does this work so well? What's under the hood? They did some deeper analysis. First, they tackled this idea that the length of the reasoning explanation matters. Some previous work used token length as a proxy for difficulty or quality. Longer explanation equals better, right?
Seems plausible.
Right.
More detail, maybe.
Well, DED's findings contradict that. They compared two teachers, QWQ32B and DeepSeek R1. The QWQ corpus actually had a higher average token length, but models trained on a shorter version of the QWQ corpus, averaging around 8,200 tokens, generated longer responses themselves and got better accuracy than models trained on the DeepSeek R1 corpus.
So wait. Training on shorter examples led to better results and longer, presumably more detailed, answers from the student.
Exactly. It strongly suggests that neither the length of the training data nor the length of the model's final output is the dominant factor. It challenges those simpler metrics.
Okay, so length is out. What else did they find? You mentioned token entropy.
Right. Token entropy, basically, it measures the uncertainty or predictability in the sequence of tokens, the words or parts of words. Lower entropy means more predictable, more structured text.
Like clear, consistent language versus rambling, unpredictable language.
Precisely. And they found the QWQ32B corpus, the better teacher in their tests, had significantly lower token entropy. Mean 0.477 versus 0.705 for DeepSeek R1. Median was even more stark, 0.090 versus 0.302.
So the better teacher was the one providing more structured, predictable, less surprising reasoning steps.
That seems to be a key factor. This lower entropy, this consistency, likely makes it easier for the student model to learn stable patterns. It promotes convergence, improves robustness, and crucially helps with generalization to those OD tasks. Clarity and structure seem vital for effective teaching here.
That makes intuitive sense. Clear instructions are easier to learn from. Anything else? There was something about PCA shift.
Yes, PCA shift analysis. This looks at the model's internal understanding, its latent representations. Think of them as the underlying patterns the model learns. PCA shift measures how much these internal patterns have to change or shift when the model learns new tasks or improves performance.
Okay, so how much does its internal map of the world need to be redrawn?
Kind of, yeah. And they found that models distilled from the Better Teacher QWQ32B showed lower PCA shift across various benchmarks compared to those trained using DeepSeek R1.
Lower shift, meaning their internal understanding was more stable. It didn't have to fundamentally rework itself as much.
Exactly. This heightened stability in the latent representations directly correlated with better generalization, better performance on new unseen tasks. It points to this idea of corpus affinity.
Corpus affinity.
Yeah, the idea that the characteristics of the teacher's data need to align well with the target task domain. It's not just about picking a smart teacher, but one whose style and the nature of its knowledge are a good match for what you want the student to learn. The way the knowledge is represented matters.
So the stability of the teacher's internal representation, reflected perhaps in things like lower token entropy, makes it easier for the student to build its own stable, generalizable understanding.
That's the implication. It suggests a much deeper level of compatibility is needed for optimal distillation than just looking at surface-level benchmarks or data length.
Okay, let's wrap this up. The big takeaway here seems to be that DED really throws a wrench into the works of the old scaling-centric approach to LLM training.
It absolutely does. It demonstrates powerfully that intelligent design, smart teacher selection, really well curated but smaller data sets, focusing on diverse reasoning can lead to top-tier results and strong generalization without needing that endless, costly scaling.
It shifts the focus, doesn't it, from just more data to smarter data and smarter training.
Precisely. And for you, our listener, think about how this might apply elsewhere, how you learn, how information is best organized. Is quality nearly always better than sheer quantity? Does focus, challenging practice beat hours of easy repetition?
And maybe a final thought to leave everyone with. If superficial things like how high a model scores on a benchmark or how long its answers are aren't the best predictors of how well it can teach, and if instead it's these deeper, less obvious properties like the structure of its language, the stability of its internal thoughts, that token entropy and PCA shift stuff, well, what does that suggest about how we recognize and use expertise in any field, human or AI? What hidden qualities might we be overlooking when we try to learn from others or try to teach effectively?
That's a really interesting question. What are the hidden metrics of truly effective knowledge transfer? Something to ponder.
Definitely food for thought. Thanks for breaking down this fascinating research.
My pleasure. It's genuinely exciting work.